Okay, good morning everyone. In the previous lecture, what we started with was the successive differentiation. So, in successive differentiation, we have seen all the basic formulas. So, for some function, you take n derivatives, and we have the formulas list of formulas. And also, we have seen some of the examples, and we stopped at successive differentiation using partial fraction. Using partial fraction. So this was the last topic that we have done. So we will go ahead with the same one, but there is a complex number basic knowledge you require once we start with this. So wherever required, I'll just tell you the statement. Now, of course, the proof is not so much important. So let's start with it. Find the nth derivative. Find the nth derivative of 1 upon x square plus a square. So how can I write this? Y is equal to 1 upon x square plus a square. Now I can factorize this x square plus a square equal to 0 as x plus ai iota x minus ai. I hope that everyone is clear with this step. This is just 11th standard mathematics by which you are factorizing this x square plus a square. If you want proof of this, what you can do is you can take this x square as minus of a square. Then x will be equal to under root minus of a square minus 1 I will write down as a under root of a square you will have, which is plus minus ai. Okay, so x plus ai, x minus ai. So this I can write as 1 upon x plus ai, x minus ai. Now we can use the partial fraction over here. So using partial fraction, 1 upon x plus ai, x minus ai, how can I write this as 1 upon, this can be written as 1 upon 2ai in bracket 1 upon x minus ai minus 1 upon x plus ai. As you can see that there will be subtraction of this imaginary part. I mean z minus z bar, which is minus 2ai, 2ai, 2ai will get cancelled out, and we get this. So y is equal to 1 upon 2ai in bracket 1 upon x minus ai minus 1 upon x plus ai. So once we have this, we have the formula for nth derivative of this type of function. So differentiating n times, differentiating n times successively. So what do we get? Yn is equal to 1 upon 2ai in bracket minus 1 raised to n into n factorial, the value upon x minus ai raised to n plus 1 minus 1 raised to n into n factorial x plus ai raised to n plus 1. So what I can do here is I can take minus 1 raised to n into n factorial common upon 2ai in bracket 1 upon x minus ai raised to n plus 1 minus 1 upon x plus ai raised to n plus 1. So up to now everything is fine, but there is a small change over here. This type of expression, as we haven't done complex numbers, this type of expression can be easily simplified using De Moivre's theorem. I'll just state the De Moivre's theorem so that you can understand the theorem says. So one thing is very much clear. A complex number x plus iy can be written in a polar form as r cos theta plus I sin theta. Okay, so every complex number can be written in the polar form, and De Moivre's theorem says that r cos theta plus I sin theta, or simply cos theta plus I sin theta, I sin theta raised to n is actually equal to cos of n theta plus I sin of n theta. So power can be taken as the coefficient of theta. This is what the De Moivre's theorem states. The same theorem I am going to use over here. So x minus ai, I will write it down as the form r cos theta plus I sin theta, which is called the polar form. This we have already studied. This is called the polar form. So what I will do is I will write this x minus ai, x plus ai in polar form, and then I will use the De Moivre's theorem in order to simplify. So let x plus ai is equal to r cos theta plus I sin theta. So conjugate of this x minus ai will be equal to r cos theta minus I sin theta. Once we have this, so from this, what we will have, the value of x, value of theta, value of r, everything we can find out. So theta will be equal to tan inverse of x by a, r is equal to under root of x square plus a square, r is equal to under root x square plus a square, theta is equal to tan inverse of a by x. Let's put this. So yn in this case will be equal to yn will be equal to minus 1 raised to n into n factorial upon 2ai in bracket. So what you have, x minus ai raised to n plus 1. So 1 upon r raised to n plus 1. By De Moivre's theorem, what I can write is cos of n plus 1 theta plus minus I sin n plus 1 theta. Look, in one step I am doing both the things. I am also substituting the value and using De Moivre's theorem. And in the other one, I will have 1 upon r raised to n plus 1 cos of n plus 1 theta plus I sine n plus 1 theta. So what we can do is we can take r raised to n plus 1 common. The value of a I have to change. So if you see, the value of a that it will have is a is equal to r sine theta. So theta will be equal to, sorry, r is equal to a by sine theta. So minus 1 raised to n factorial upon 2ai r raised to n plus 1. You do the cross multiplication, cos of n plus 1 theta plus I sine n plus 1 theta minus cos of n plus 1 theta plus I sine n plus 1 theta divided by 1. Can anyone tell me how it is 1?
So cos square
Sir,
theta
it will
plus
become cos square plus sin square.
yes,
Cos
sir.
square theta plus sine square
That's
theta.
right.
Yes, exactly. So a minus b and a plus b. So that will be a square plus b square ultimately. A square minus b square. So I and I will be minus 1, which will make the plus 1. So sine square cos square, that is becoming 1. So again, simplifying this further. So what we will have is 2ai sine theta. 2i sine theta. So this is equal to minus 1 raised to n into n factorial upon 2ai r raised to n plus 1 in bracket 2i sine of n plus 1 theta. So 2 will get cancelled out. I will get cancelled out. Now just look at this. What we have put, how do we get a polar form? If x plus iy is there, then you put x is equal to r cos theta, y is equal to r sine theta. And when you put this in this equation, what you get is r in bracket cos theta plus I sine theta. But actually, this is the substitution that you do. X you write it down as r cos theta, and y you write it down as r sine theta. Yes. Now, what is our y in this case? I have put x plus ai. So a is equal to r sine theta. Is everyone clear with this step?
Yes, sir.
Yes,
Yes.
sir.
So now the value of a is equal to r sine theta. So r is going to be a by sine theta. I'll write it down a bit properly. So r is equal to a upon sine theta. So we'll substitute this here. What we have is minus 1 raised to n factorial. You have a upon sine theta raised to n plus 1 into sine of n plus 1 theta. So this can be written as minus 1 raised to n factorial sine of n plus 1 theta sine raised to n plus 1 theta divided by a raised to n plus 2. So even we have done the proof. The proof is not so important. So again, these two formulas we will write it down on a new slide. You make a note of it in your notebook if you are writing down the notes. So if y is equal to 1 upon x square plus a square, then yn is equal to minus 1 raised to n into n factorial sine of n plus 1 theta sine raised to n plus 1 theta upon a raised to a raised to n plus 2, where theta is equal to tan inverse a by x. The same thing, whatever we have done, can be done for this function too. If y is equal to x upon x square plus a square, then yn is equal to minus 1 raised to n into n factorial cos of n plus 1 theta into sine raised to n plus 1 theta divided by a raised to n plus 1, where theta is equal to tan inverse of a by x. You can remember this final formula, both of them. Why there is cos of n plus 1 theta, you can, think over it, or you can directly try to prove this formula and you will see why you are getting cos of n plus 1 theta there. Fine. If y is equal to tan inverse x by a, who can tell me? Can someone do it? It's very easy.
तो फर्स्ट फॉर्मूले में n की जगह n-1 सब्स्टिट्यूट कर देंगे.
Cos formula में. Okay,
नहीं,
do it. Tell me the final answer. Tell me the final answer.
-1 की पावर n-1 इंटू n-1 का फैक्टोरियल अपॉन a की पावर n+1 then sin n theta into sin raised to the power n theta.
Good. It is almost right, but not exactly right. You have done a small mistake there, taking the derivative of tan inverse x by a. So what will be y1? Y1 is equal to 1 upon 1 plus x by a square into derivative of x by a is 1 upon a. So this is going to be a upon x square plus a square. So a I can take outside, 1 upon x square plus a square. Now how many derivatives I have to take? N minus 1 derivatives. So n minus 1 derivatives. So minus 1 raised to n minus 1, n minus 1 factorial, a raised to n plus 1 will be there. This is inside bracket, sine of n theta, sine raised to n theta. और बाहर एक a था. This a will cancel out with this plus 1. So the formula is minus 1 raised to n minus 1, n minus 1 factorial, sine of n theta, sine raised to n of theta divided by a raised to n. You can add these three formulas. You can also derive what happens when it is a by x, tan inverse of a by x, that too you can derive, but I'm not going to go into that detail. I'll immediately go for the example. Find the nth derivative of, find the nth derivative of y is equal to tan inverse under root 1 plus x square minus 1 divided by x. Yes, anyone? Daksh,
Sir, trying.
you have become too much silent, Daksh. Earlier you were asking problems and you're active.
Okay.
Okay, so what we will do is, we have y is equal to tan inverse under root 1 plus x square minus 1. If the question was to just find out the derivative, what you would have done is, you would have simply put x is equal to tan theta. So what we have, tan inverse of 1 plus tan square theta minus 1 divided by tan theta. So this is equal to tan inverse 1 plus tan square theta is equal to sec square theta minus 1 upon tan theta. So this is tan inverse of sec theta minus 1 upon tan theta. So this we will have to simplify. Tan theta is sine upon cos, sec is 1 upon cos. So y, I will write it down as tan inverse of 1 minus cos theta divided by sine theta. So sec I
Tan
am like,
inverse tan theta by 2.
yes,
Tan inverse tan theta by 2.
yes, it is correct. So y is equal to tan inverse of 1 minus cos theta is equal to 2 sine square theta by 2. Sine theta is equal to 2 sine theta by 2 cos theta by 2. So 2 will get cancelled out. Sine will get cancelled out. And what we have is tan inverse of tan theta by 2. So what we have got is y is equal to 1 by 2 theta. Theta is nothing but tan inverse of x. Right? Just now we have seen a formula. If y is equal to tan inverse of x by a, then yn is something. Okay, so now differentiating n times successively. Yn will be equal to 1 by 2 as it is, minus 1 raised to n minus 1, n minus 1 factorial, sine raised to n theta, sine of n theta divided by a raised to n. A in this case is 1, where theta is equal to tan inverse a by x. Clear? Find nth derivative of y is equal to cos inverse of x minus x inverse upon x plus x inverse. Do it.
So if we take x is equals to tan theta, then it comes cos inverse equals to minus cos 2 theta. Correct.
What you are substituting?
X is equals to tan theta.
Yes.
The
I
root
got
cos 2 theta.
So what we will have is the final simplification of it is pi plus 2 times.
no. So I got pi minus 2 times tan inverse x.
Yes. So you're getting pi minus. You've got minus cos 2 theta, right?
Yes, minus cos 2 theta.
Minus cos of 2 theta. So that you are writing as cos of pi minus 2 theta.
Yes,
Pi minus theta. Pi
it should
minus theta.
become minus 2 tan inverse x, right?
Yes. But I think it has to be pi plus 2 theta. So anyway, cos of pi minus 2 theta, pi plus 2 theta, both are negative. है ना?
Yes, sir.
So the final answer is 2 times minus 1 raised to n minus 1, n minus 1 factorial, sine raised to n theta, sine of n theta. So we'll start with the new topic now. Topic is, subtopic. The subtopic is Leibniz theorem. If in case you are giving this exam offline, then in successive differentiation, this is the most important topic. And it depends on one small theorem, and the theorem is Leibniz theorem. Leibniz theorem. The theorem states that if y is equal to u into v, where u and v are functions of x, then yn is equal to n c0 un into v plus n c1 un minus 1 v1 plus n c2 un minus 2 v2, so on, and this goes up to n cn u into vn, where suffix represents the number of derivatives. We'll just recall what is NCR. NCR is equal to n factorial upon r factorial n minus r factorial. So if you have NC0, then this will be n factorial upon n minus 0 factorial. So NC0 is always 1. Okay. So NC0 is 1. What is NC1? You will have n factorial upon 1 factorial n minus 1 factorial. So when you cancel out n minus 1 factorial from n factorial, what remains is n. NC2 will actually be equal to, so you will have 2 factorial into n minus 2 factorial. So n minus 1 divided by 2. NC3 will be n minus 1 n minus 2 divided by 3 factorial. That's it. This many terms you will need. So you either you can remember this formula in terms of NCR, or what you can remember is yn is equal to unv plus n into un minus 1 v1 plus n minus 1 into n divided by 2 into un minus 2 v2 and so on. We'll just write down a small remark. The remark is of choosing u and v. Look at this. Okay, this is kind of a series. I mean, अगर n infinity पे है, y is equal to sin x cos x, y is equal to sin x and cos x. Writing nth derivative in this case will be difficult. I mean, you will have kind of a series over here that won't end at any stage. Okay, so this formula is very much helpful when either u or v is a polynomial. So Leibniz theorem is useful when either u or v is a polynomial. A very important remark. Leibniz theorem is useful when u or v is a polynomial. Now, which one is to be chosen as a polynomial? Anyone? Which one is to which? I mean, u should be polynomial or v? What is important thing about polynomial? What remark can you make when you take the derivatives of a polynomial?
So u should be polynomial.
Because
So वो zero हो जाएगा नहीं तो.
v should be a polynomial because the first term, in the first term, if you see, v is kept as it is. In the second, you're taking one derivative of v, then you're taking two derivatives of v. If you have a polynomial, then say I will take for an example v is equal to x square. So what will happen? The first one will be x square, the second term will have 2x, third term will be 2, and from fourth all of them are 0. Okay, so polynomials should always be v, because after 2 to 3 or 4 terms everything else will become 0. So v should be chosen as polynomial. Fine. So Leibniz theorem only useful when either of them is a polynomial. Which one has to be a polynomial? V should be a polynomial. Fine. As everything is clear about this theorem, we'll solve some examples. Find the nth derivative of first one, x square e to the power ax, which is a polynomial.
X
V
square.
X
is
square.
equal to x square, u is equal to e to the power ax, differentiating n times using Leibniz theorem. So yn is equal to un into v plus n into un minus 1 v1 plus n into n minus 1 upon 2 un minus 2 v2 plus n minus 1 n minus 2 divided by 6 un minus 3 v3. देखो third derivative of x square is 0, so this term is going to be 0, so I can remove this term and all the further terms. So what do we have is, let's write down un. Un is equal to a raised to n e to the power ax. Un minus 1 is a raised to n minus 1 e to the power ax. Un minus 2 is equal to a raised to n minus 2 e to the power ax. V is equal to x square. V1 is equal to 2x. V2 is equal to 2. And so yn is equal to a raised to n e to the power ax into x square plus n into a raised to n minus 1 e to the power ax into 2x plus n into n minus 1 divided by 2 a raised to n minus 2 e to the power ax into 2. So this 2 will get cancelled out with this 2, and this is our final answer. If you have any problem, you can ask. Okay, you can try one example now. Y is equal to second one. y is equal to x square e to the power x cos x. What is u? What is v?
V x square and u
U
e
is
to
e
the
raised.
power x cos x.
So the x square dx.
Yes, exactly. So v is equal to x square, u is equal to e to the power x cos x. Take the derivative, nth derivative of e to the power x cos x, you know, by our list, which is r raised to n e to the power x cos x plus n times theta. How many terms? First three terms will be there. So yn is equal to root 2 raised to n e to the power x cos of x plus n times pi by 4. Please check the calculations. Into x square plus n into root 2 raised to n minus 1 e to the power x cos of x plus n minus 1 pi by 4. Derivative of x square, which is 2x plus n into n minus 1 divided by 2 in bracket root 2 raised to n minus 2 e to the power x plus n minus 2 pi by 4 bracket complete. Derivative of 2x is 2. This 2 will get cancelled out. That is our final answer. In our successive differentiation, just one last type of examples are remaining, that we will do it in the next lecture, and then we will start with the next topic or the next chapter. Is anyone having problem in this?
So where did that root 2 come from?
You have the formula for nth derivative of e to the power ax cos of bx. Uh, in that formula, the value of r is under root of a square plus b square. In this, a and b both are 1. So under root of 1 square plus 1 square is root 2. Right?
Sir?
Yes.
Sir, I was absent in the successive differentiation when you were teaching this. Sir, I just want to ask why we are finding this successive differentiation, means what is our motto after finding the answer?
You will see in the coming lectures that we will be able to expand the functions into series by using nth derivative. In one or two lectures, you will understand it why we have studied successive.
Okay, sir, thank you.
Okay, thank you everyone.
Thank you, sir.
Thank you, sir.
Thank
Thank
you,
you,
sir.
sir.
Thank you, sir.
Thank you, sir.